Hello, I'm here today with Venki to talk about his PhD in the DCU School of Computing. So Venki, tell us a little bit about yourself.
Hello, I'm Venkatesh. You can call me Venki. I'm from India. So my field of research is in computer science, which involves like computer vision, image processing, deep learning, and more towards the autonomous vehicles or self-driving cars. So I finished my undergrads, bachelor's degree in India at NITI Meenakshi Institute of Technology, affiliated to Visvesvaraya Technical University in 2010. And I did my final year project in image processing, so which kind of motivated me towards learning more about or knowing more about image processing. After finishing my graduation, so I joined as a research associate in the same institution in Center for Robotics Research, which worked on our robotics, like multidisciplinary robotic research involving mechanical, computer science, and electronics. And I was involved in developing algorithms for image processing, like for robotic applications. And therein I worked more on with computer vision applications like door sensing, mobile robots, and outdoor mobile robots, and mobile robots. And after working for 3 years and having some experience in image processing, and I thought of doing my master's. So I joined to the master program in the same institution in computer network engineering, and my final year master's thesis was for video summarization, basically having the keyframes or keyframe extractions in the input video and basically summarize your entire video in few shots. So that was my final year project, and like having worked with academics for 3 years, having research experience in academia, so I thought of having the industrial experience. So after finishing my master's, so I joined to an automotive company, Continental Automotive, which gives solutions for the autonomous or automated driving vehicles. So like here I worked in research and computer vision research and development group, and basically focusing for traffic sign recognition. So after working, I worked here for 3 years and basically developing the algorithms or giving solutions for traffic signs. So while working in the company, I wanted to enhance or to extend my knowledge in computer vision. So I was looking for a PhD. After working 2 years in the company, I wanted to do my PhD. So I was continuously looking, and one of my colleague who was working in my company, he joined as a postdoc in Insight, and after 1 year he just shared me a position, vacant position in the Insight. So after which I applied here, and I had an interview with Noel O'Connor and Suzanne Little. And after which the interview went successful, and they offered me a position. So not the PhD position, but they offered me a research associate research assistant position for the initial few months. And depending on my performance, they told, okay, depending on your performance, we'll see how that can be extended to your PhD. So that's how I came to DCU. And from the start, I have been working with the solutions for the autonomous vehicles. So I have been involved in the VDAS project, so which is vision inspired autonomous driving systems. And after 6 months, I have been offered with the PhD position here. So now I'm in my second year of my PhD, and basically working with the object detection part for autonomous vehicle, which is which is the part of the perception system.
So what is your PhD about?
My PhD is about the perception system for self-driving cars, and it's basically to improvise the system mechanics, how to identify the different driving conditions, and how to localize or how to detect different objects which will be there in front of the car. Say for example, it could be a vehicles in front, or the pedestrians, or the traffic light. So this all comes under the perception systems, and the vehicle should be able to identify these objects, and it should be able to localize. Basically, it has to give the range at what distance the object is and take the necessary actions. And yeah, this is about my PhD. Yeah.
So so I know like image detection is like is a field that's been around for a while. So what's your contribution, and would you say, like, what are you doing differently in terms of perception system?
Yeah, one of the major challenge in self-driving cars is the perception system, which is like though we are able to detect the objects, but it is like to what accurate we are able to detect, and how safely we can navigate in the real world is very challenging, and still it's an open challenge problem, and people are working on it, and still they are finding this gap. So my objective is to use the different sensories which will be there in the self-driving cars. Say we have this camera which gives the live feed information of the of the scenes, and the range sensors which gives the distance between the object and the car, and basically to fuse these two information, to join these two information, have process it, and have the accurate the object, what it is, like what I'm looking for, and at what distance the object is there from the vehicle in which I'm driving. So this is the actual contribution of mine, to have a better system to localize, to detect the objects, and to have at what distance it is.
Okay, and then just to get a little bit more technical then, so how would you go about doing, first, how would you go about fusing the data, and then I assume you're probably using some kind of neural net architecture to do that?
So the solution, what I'm planning to adopt is the deep learning based solution, which is the buzzword now. So the deep learning based solutions, wherein now, like how? So now when we take any object in the real world, so it has its own dynamics, so it has its own shape. And if I'm able to detect that particular objects from the image or from the video, but I am not sure at what distance it is, the depth, basically the depth. From these range sensors, so like we basically use the LiDARs, so light detection and ranging sensors. Using that, we'll get approximate distance. With this, we also can estimate what is the size or shape of the object. So which is kind of like we can get the depth at each point. And now in the real world, what it is like, we also have the temporal information. So as the vehicle is moving, even the object is also moving, and how the shape of the object is moving, whether it is increasing, or if it is increasing, in the sense like my vehicle is going very close to the object, or if it is like very small. So it is like the object is in like it's in moving fast, or it is the vehicle is stopped, or something. This information is there. So basically, what my plan is to like study this information, and based on this, like learned like dynamics of the object, or the depth information of the object, from the temporal information over it, which is like changing your object shape or size over a period of time, improve the detection part. So wherein accurately have the estimation, even though there are some failures in detection, you will be able to detect it. So it's kind of a prediction as well.
Okay, and then finally, our last question is like, so why is your work important?
As I said, for self-driving cars, the perception system should be more or less very accurate. So you can't have any errors in it. And in the near future, like what we are expecting is the self-driving cars like to have kind of a smart mobility. You don't have to like bother about like what I'm like, even if you are getting distracted, it is like it's okay, that vehicle will take care of you. That's how the smart mobility is about. And even smart mobility also have this kind of like mitigating the lesser accidents, or like very crucial accidents, or like reducing each and everything. So that's how my research will be helpful in kind of like having a better perception system, and thereby increasing the error rate, which is very quite common in present autonomous vehicles.
Okay, thank you very much for telling us about your work.
Thank you.